Welcome to presentation number 2 in model number 4. Okay, so here in this particular video we are going to study about the various components of tidal power. Okay, so we will study in detail what are the important essential components of this tidal power. Essential components of tidal power plants. There are three main components of tidal power plants. One is powerhouse, second one is dam or barrage, okay, or a barrage, which is called as low wall, or a low wall to form a pool of water, or which is termed as basin. And third one is sluice ways from the basin to the sea, and vice versa. Okay, so we will discuss in detail about all these components. We will take up first powerhouse. Before going to explain about powerhouse, in diagram you can able to see the tidal barrage, okay, tidal barrage, and turbine tunnel, and you can able to see sluice gates. Okay, so these are used to operate the tidal power plants. Okay, so tidal barrage is will produce the water level, okay, or creates a basin, whereas turbine tunnel, over that you can able to install turbine. Okay, sluice gates are used to control the rate of flow, or water flow, okay, from the high tide range, tidal basin, to low tide basin. Okay, so we will see discuss one by one. The first one is powerhouse. The powerhouse consists of turbines, generators, and other auxiliary equipments. Because of small heads only are available, the small heads available, the large size turbines are needed. Hence, the powerhouse is also a large structure. Okay, so there are two types of turbines used in tidal power plants, which is called as the bulb turbine, or and rim type turbine. Okay, bulb type turbine or rim type turbine. Before going to see what is the bulb type turbine and a rim type turbine, I want to explain about dam or barrage. Okay, the function of the dam is to form a barrier between the sea and the basin, or between one basin and another, in case of multiple basins systems. Okay, as the barrage has to withstand a large force of sea waves. Okay, so the design should be suitable to the site condition, and it should be economic, and it is economic, except or we can say it should be economic aspect of development. Okay, so here we will see the different types of turbines. Powerhouse. As I mentioned earlier, there are three types of turbines, isn't it? So bulb turbine, two types: bulb turbine and rim type. In systems with the bulb turbine, water flows around the turbine. Okay, this is the sketch for bulb turbine. Water flows around the turbine, and it makes assess for maintenance, excess for maintenance difficult, as the water must be prevented from the flowing past the turbine. Okay, whereas in rim turbine, it reduces the problems as the generator is mounted in the barrage. Okay, in the barrage, and which is at the right angles to the turbine blades. Okay, so you can able to see here generator at the barrage. Okay, and it is right angles to that. Unfortunately, it is difficult to regulate the performance of these turbines, and it is unsuitable for use in pumping. So one more type of turbine is introduced in UK projects, which is called as tubular turbines, which have been proposed for use some UK projects. In this configuration, the blades are connected to a long shaft and originated at an angle so that the generator is sitting on the top of the barrage. Okay, so you can able to uh, see here, this is the generator, isn't it? So you can able to see here a generator is sitting or situated at the top of the barrage. Okay, so uh, by this, these are the three types of turbines. Okay, so you can able to see one more sketch. Okay, next is dam or barrage. As I mentioned earlier, you can able to see you can understand by seeing this sketch what is dam or barrage. Tidal power barrage have to resist waves whose shock can be severe, and where pressure changes continuously. Okay, so barrage needs to provide channels for the turbines in pre-stressed or reinforced concrete. Barrage has integral gates allowing the area behind it to fill the seawater at a flood tide, emptying on the ebb tide through water turbines that generate power. Okay, so the basin is filled through the sluice and freewheeling turbines until high tide. Okay, then the sluice gates and turbine gates are closed. Okay, by when it is closed, uh, the flow will stops, isn't it? So they are kept closed until the sea level falls to create a sufficient head across the barrage and the turbines, which will generate the head again, until the head is again low. Okay, then the sluices are opened and turbines are disconnected and the basin is filled again. Okay, so ebb generation is also known as outflow generation. Okay, which will takes it's the same its name because generation occurs as the tide ebbs. Okay, so next important parts is sluice ways or sluice gates. These are used to fill the basin during the high tide, or to empty the basin during the low tide. Okay, and it depends on the requirement. Okay, if the base if it is used for fill the basin or to empty the basin, these devices are controlled through gates. Okay, so there are two types of sluice ways. One is called as crest gates, and second one is called as submerged gates with the venturi type. So crest gates and submerged gates you studied in hydroelectric power plant, so I'm not going to explain again here. So this is about sluice base.